you about what we've been doing with Rust training over the last 3 years at Google. The goal of the talk is to show you what we have done, something that you can use, and hopefully inspire you to take a look at this and maybe apply that in your own large organizations. So, just to set the stage, I want to start by telling you where we found ourselves in Android and, in some sense, the industry at large, roughly 5 years ago. This chart from Microsoft Security is, in some sense, a big reason why I'm here today, and maybe why a lot of you are here today. They have looked at the past security vulnerabilities over a 13-year period, all the way back from 2006 here on the left to 2018. And we are talking about hundreds of vulnerabilities per year. They categorized them, found that the root cause at about 70% of the vulnerabilities were memory unsafety. And this is despite huge investments, right? Sanitizers, fuzzers, coding practices, all of these good stuff had been heavily invested in, and yet the proportions stayed remarkably constant at around 70%. The keynote on Wednesday also touched on this 70% number, and it's something that we've seen across many teams and in different parts of the IT industry. Blog post from Android and Chrome pointed out similar numbers. Here, Android in 2019 found that 90% of the vulnerabilities were caused by memory unsafety. Chromium, a little bit later, found something about the 70% number again. One thing to remark here is that these are the high and critical severity vulnerabilities. It means these are the worst of the worst ones. Because what happens, as hopefully people here know, is that memory unsafety is often leading directly into undefined behavior, which often leads directly into the kind of vulnerabilities where people get remote code execution, they get access to take over your entire system. And this is the main reason why we want to stop these kind of vulnerabilities at their source, because they are, the worst of the worst. So, because of this kind of situation, Android was starting to look into how could we add more memory-safe code to the Android platform. Here I'll just make a note and say, when I say Android, I'm really talking about the large system that is running below the Android apps. Android apps are written in Java or Kotlin primarily, and they are already memory-safe. But I'm talking about this big system that, in my mind, is really just a Linux distribution shaped to run on a mobile device. And like any Linux system, there's a lot of system daemons on such a thing. These daemons handle things like the Bluetooth stack, the network stack, give you access to sensors and other hardware. They implement all the APIs that the Android apps are calling. And this kind of software is primarily written in C and C++. And this is where the dangers come in. So this system, the Android open source platform, AOSP, has then added support for Rust to its build system. That was the system Zoom that Frederick mentioned this morning in 2019. And 2 years later, we declared that Rust was a fully supported, generally available language for Android platform development, and encouraged teams to start using this. The best part about this, and there's a blog post that you can read, and you'll find the link in the Discord, is that we can actually see the effect of adding more memory-safe code to the Android platform. As we have added more Java, Kotlin, and Rust code to the Android platform, the number of vulnerabilities caused by memory unsafety has gone down. So now, the challenge that we faced was that Android is a very large system. There are thousands of engineers inside Google working on Android, thousands outside of Google working on Android, AOSP, customizing it before shipping it to the end users. And we would like to now have these developers actually ramp up on Rust, start using Rust. So how can we do this in an efficient way in terms of the time and effort that engineers have to spend to get familiar with the new language? In particular, how can we move beyond the early adopters? How can we reach the engineers who don't spend their free time, their evenings and weekends reading the Rust book, the amazing videos, blog posts, and actually engage in this themselves? I'm sure many in this room have learned Rust for fun because you found it interesting, you saw the qualities, you were attracted to these special features that the language has, but we cannot expect thousands of engineers to do the same. And there were further requirements/constraints that we wanted to, in some sense, take advantage of. One of the things at Google and Android is that we wanted to move experienced developers to Rust. People who already write C and C++, low-level technical stuff. We wanted them to start using Rust, and we wanted to take advantage of essentially a stronger base assumption than most material that we find online can make. We also have, of course, busy teams with deadlines. We want to have something that was of a fixed duration in our material. A lot of the excellent online documentation and material about Rust is for self-paced study. It is open-ended. You go read the Rust book and it takes a while. But we needed something that was more concentrated, and also concentrated from an information density point of view. Our goal was to have people become productive in Rust in days, or let's say weeks, but not months. We wanted to really, in an efficient way, move people to this new language. And a big part of that was that we felt that we needed to have a lot of interaction and engagement so that people could quickly try out their ideas and challenge their assumptions. Okay. It also needed to scale, of course, to big sizes. And out of the existing material out there, the one that is most like what we ended up with is the Rust by example page, which has interaction in the foreground. Everything is, you teach yourself Rust by going through a series of examples. So the conclusion is that we ended up writing a Rust course specifically designed to be taught in a classroom. The course is based on a bunch of slides, it has exercises, and in particular it has speaker notes for instructors like me and other people who have picked it up, but maybe some of you. The goal is to make it easy for new instructors to get started with the course and start teaching it. Interaction is a key element of this, is front and center of everything, and I'll show you in a second. And we published a blog post last year with more background detail that you are invited to take a look at. So, Comprehensive Rust is what we named the course that we created first. Actually, we started with one course, but then, we were teaching the course, and then people had more ideas and more things we should add, and we should cover concurrency, we should cover async Rust. So we have now split Comprehensive Rust into, we think of it as a family of courses. So Rust Fundamentals is the 4-day course that covers everything we believe a Rust engineer should know. The syntax, error handling, broad spectrum of the language. It's not specific to Google, it's not specific to Android in any way, it's just generic, good Rust information. And on top of that, we have, at the moment, 4 different deep dives. The concurrency in Rust deep dive is also applicable, I think, to every engineer, basically. But the others are more covering specialized topics that probably more for people working on the Android platform, as an example. This material has been taught in the classrooms at Google for more than 2 years now. We have continuously adjusted it and refined it. We have gotten feedback from the instructors and from the students, and based on that, we have been updating it and adjusting it. It's one thing I'll say is that you cannot make anybody a Rust expert, I think, in 4 days or even 8 days if you take the whole package here. But we hope to give people a solid foundation. We hope to teach people how to think about Rust and ask the right questions and find the answers to some of these questions. One of the things we make an example of is to talk about how does the standard library documentation work. So as part of the class, we will go into the standard library documentation and search for the relevant methods to solve whatever the students might have as a question. And this is an important part to become, I think, a proficient Rust developer, is to be familiar with this broader ecosystem. How do you find a good crate, for example? This kind of thing. So, in line with this, with the track, we also wanted to reach global audiences. So, not just we are not just covering a large part of the language. We also cover a bunch of spoken languages. So this is how the very first top of the page looks in English, but this is how it looks in Brazilian Portuguese. And here we have it in Korean, and here we have it in simplified Chinese. So this was particularly important for Android,
where I come from, because we have these partners around the world who take the open source part of Android, customize it before shipping it. We wanted these partners as well to be able to ramp up on Rust and use the Rust code and adapt it as we add more and more to the open source platform. We wrote a plugin for Emptybook for this. Emptybook is the tool that generates all the HTML of all the Rust books that you are hopefully familiar with. It's also open source, and it's been used by a few other projects now in the Rust ecosystem, and it's been super cool to see, and we hope that this will be useful for many more projects. So here we come to the tricky part, where we will see if the demo gods are with us. Let me go here, and then I go here. Yes, so back to full screen. So what you see here is the generated output. Okay, here we go. So this is a normal Rust book as you know them. There's the sidebar out here. You see how the course is split into mornings and afternoons, and we cover the whole language. That's the ambition. So right now it doesn't look like a course very much, but this is because we do two things. First of all, we have a speaker note down here, which is trying to give information to the instructor and also to the students who hopefully open this and browse this themselves, so there's some extra background material often. The first thing you would do when you want to present this is to click this little button, a little bit of JavaScript pops it out, and yeah, we can let this one go away. Except, no, why did it not go away? Here we go. So now we have a bit more clean slide. You close the sidebar, and then you zoom a little bit. So now we have something that feels more like a slide in a classroom. The arrow keys go back and forth. This is just normal Emptybook. It's all very nice. And what you now see dominating is the interactive playground. And this is how we essentially teach the language through live coding. So if my internet connection is still here, we can run this code and you get some output. And what we do is we tell instructors to ask for questions. We really try to make this a live coding experience. Sometimes we have left strategic comments behind that can illustrate different points, key points here. The compilation will now fail because Y does not have, you cannot find a type that matches the two signatures of the functions. And this then gives the instructor a great opportunity to talk about the error messages that Rust C gives us. Because this is something we've found. When we take existing developers and the compiler spits out multiple pages, they're like, okay, fine, I'm not going to look at this. This is typically not so helpful. They've taught themselves to disregard it. So we need to unlearn that and actually make a point out of, hey, this is what happens. You need to read this. This is often helpful. And as an instructor, I can tell you that it's almost too helpful because the compiler solves most of my exercise. Some of my exercises are solved by the compiler being so incredibly helpful. So this is, incredible quality of the diagnostics here. So let me go back to the slides, and then I should click here. Yeah, great. And this was just in case the internet was broken. So now this is what we did. We wrote this course covering multiple days, and now I'll just tell you a bit about what did we learn from this. So as I said, it's been taught for more than 2 years at Google. We have run more than 100 classes in total. Primarily the 4-day Rust Fundamentals class these days. That's what we try to schedule most. And then we add in the deep dives once in a while. Maybe a team comes and says, hey, we really want to learn something about bare metal programming. Then we try to find someone who has the expertise in that and teach that class. We have an internal e-learning platform, of course, and this class has the highest score of any programming language course taught at Google right now, which I just found out a few weeks ago, and I was, of course, pleasantly surprised. And this is primarily because of the interaction. This is the killer feature for this class. What happens is that people come into a room and they sit down and they expect to have a normal presentation. And then they see there's some playgrounds. Okay, fine. Code on a screen, nothing fancy. They see us run the code and okay, there's a video. Not so fancy. Then they see the instructor start interacting with this, and this is probably still a recording, they might think. And then they see the instructor making a typo. That happens sooner or later, you're going to make a typo as an instructor. And then compiler errors occur, and people are like, okay, they really you can see them sit up in the seats and actually pay a lot of attention. It's a wonderful experience to teach the class, I can say. But it lets the instructor adapt the material in real time to the students, which is a very special thing, it turns out. People feel heard and seen in a very special way when they can ask questions and the instructors engage with these questions. And we encourage the instructors to do this. It of course requires a certain amount of knowledge about Rust, and you need to be a little bit brave, I guess, to do this live coding in front of people like this. But people tell us in the course feedback that they absolutely love this. They are taking on a journey through a language in a different way than if they were just passively being fed information. And they can challenge their understanding immediately, and that is the thing that is key here. People shout out questions, say like, how does this work, and what will happen then, and vice versa with the instructor, and say, what do you think happens here? And then we can run the code, and we can try it out. Yeah, people have been, basically, from the beginning, consistently highlighting that this was surprising to them. They thought 4 days was too much time, but they actually came back afterwards and said this was really, really nice. Another thing that we did that has worked out really well was that we developed this fully in the open. It's on GitHub, Comprehensive Rust. And I want at this point to give a big thank you to the more than 300 individuals who have helped make the class what it is today. This is something that started I started writing it, but it has grown way beyond what I could do. And it's only because of all these people that have helped out, spending their time writing bug fixes, fixing my many typos, improving my English, and writing also new exercises, making new translations, coming with deep and thoughtful comments about how we could restructure the flow and improve things. This has been really, really impressive, and really, I'm very grateful for the community for this warm welcome. So thank you all very, very much for this. Big hand to the people. And it's only, I would say, like maybe 80% of these are not from Google. So there's really like the broader community have really helped us a lot, and helped all of the thousands of people who come to look at the course. Of course, things were not perfect out of the box. 2 major pain points were exercises. We started with a block in the morning and a block in the evening, afternoon. It turned out people wanted more Rust. They were like, we want to program more, we want to have more exercises. So we rewrote the course and split them into smaller exercises. And then also, Rust is a very large language. It is hard to teach everything in a nice topological sorted order where you never depend on things you haven't actually touched on earlier. So we had some problems with that in the first version, and we reshuffled and rewrote it to address most of that. And please open more issues and pull requests and so on as you find problems. Also, as we rewrote it, we took an opportunity to use what is called a spiral approach, where we on purpose lean heavily on the existing experience of the students. So you all know what a function is. We don't need to go deeply into what a function is the first time we show it. And then later we can come back to this and touch upon it more and more. Finally, I want to tell you a bit about how people have used Comprehensive Rust. It has been taught in several places outside of Google. For example, there's a 5-day elective class at a German university. I know this because of the blog post that the author wrote, so thank you very much for that. And I've been told privately by at least 3 different vendors that they've been teaching Rust to small and, in some cases, very large companies. And I'm always curious about hearing more about this if you can and will tell us. And it's been amazing to see how we hope to reach people in many different contexts. Now, some final words about how you could apply this in your organization. And honestly, teaching is probably not, and training is probably not your first step in a very large organization. You will probably want to find some early adopters, find some people who already know some Rust, have them do a pilot project, use this to identify problems that you then address, and then you repeat this a few times. So for example, what I said about Android, we integrated support for the Rust compiler into the Android build system. We are not using Cargo, we're using this thing called Zoom, so that took a while and required some work. Maybe you have logging and metrics infrastructure critical to your observability of your applications. You need to add some support for that and integrate that into Rust. So there's going to be some iteration here. Take it slow and make sure you have a solid foundation. As someone told me, you only get one chance of making a first impression to your large organization, so make sure it's a good one. Other things that we did in Android, I can recommend, is to make books and resources available to your engineers. Set up chat rooms internally so that people can find your Rust experts and actually connect with them and ask questions. And at some point, you probably want to offer some sort of classroom training. And for that, we can recommend using a vendor. We hired a company, Immunant, to teach the classes repeatedly and consistently. This also helps with the challenge of the instructors doing all this live coding, because these instructors, after doing this a few times, they know what the common questions are and how to tackle this. Something that can help you bootstrap your team. At Google, more than 40 engineers around the world have picked up the class and started teaching it. Something people can do in weeks. If you already know Rust well, you can take the material, you read through it, and then you can actually start teaching this very quickly. That's our experience. So, again, link to the Discord. The final words from me would just be a big thank you to the Rust community for the warm welcome we've gotten with this course. We hope to empower people around the world to both learn Rust themselves as a self-paced study via the speaker notes, but also to teach Rust to their fellow communities in organizations and meetups around the world. So thank you very much to all the very many people who have helped us make the course what you see today. Thank you.